Okay, so let's start talking about binary, permutation, communication, and dominance matrices. We're going to do this in a few parts. So we use matrices to represent real-life situations such as communication links between people and ranking sporting events. So we've got these real-life situations. We can use a matrix to model it. Okay, so in further maths, we want to demonstrate understanding of communication and dominance matrices. Okay, prior to 2016, with our new study design, this was in our networks module. Okay, let's start talking about the binary matrix. The binary matrix is a matrix that will only have ones and zeros as its element, no other numbers. So we use these to analyze communication systems and dominance. Okay, so we're going to be using those a lot now. So they only have ones and zeros. So the first example that we're looking at is the permutation matrix. Now, permutation is change. Okay, so it's something about change, so keep that in mind. So change. So a square matrix, so a permutation matrix, I should say, is a square binary matrix where there's only one in each row and column. Everything else is zero. Okay, so what is it used for? It can be used to rearrange the elements in another matrix. So it changes how another matrix, the order that it's in. Okay, it rearranges it. So when you see a square matrix with only ones and zeros and only one in each row and column, there's a permutation matrix. So let's look at an example from an exam to see it in action. This from the 2017 exam 1. This is question 4, so about medium difficulty. A permutation matrix P can be used to change this matrix into here. Now you can see this first one, fears. Okay, we're using the same letters in safer, but they've just been rearranged. So this F, instead of being in this first row, is now in the third row. E is now in the fourth row instead of being in the second. A is in the third instead of was in the third, now in the second. R was in the fourth, now in the fifth. S was the last one, the fifth row, and now in the first row. So what has been done here? Okay, I might actually tell you the answer for this one, and then we can go through why it is so. And you can probably see we can eliminate A and D. Why can we eliminate A and D? You can see they've got more than one in rows and columns. So, immediately you can discount that as being a permutation matrix. So a permutation matrix is taking this and changing it into that. Okay? Taking this and changing it into that. Now, our permutation matrix we can see is a 5 by 5. Our original matrix is a 5 by 1. Okay, so I'll place this here. So fears. And let's go through why this is the answer. Okay, remembering we've got a times row by the columns. Okay, so you can almost think for a permutation matrix that it's like the zeros are turning off and ones are turning things on. Okay, so 0 times by F, 0, 0 times plus 0 times by E, 0 plus 0 times by A, 0 plus 0 times by R, 0 plus 1 times by S, well, that's S. That's one we want. Here we've got 0 times by F plus 0 times by E plus 1 times by A and the other two are 0. This third row, it's only that 1 times by F, all the rest is 0. So F. Here I've got that 1 turning that E on. And this one, that's that R, isn't it? That's the only one can be. Okay, so 74% of the state got that one correct. Now, looking at the rest of these, okay, to discount B or E, have a look at, go through and have a look at this. B, you can see, that's the fourth one. So the first, if we were to times it by fears, very badly written, but you can see that the first one there is R, isn't it? So that is not going to turn this into this. Even this second row, was going to get A, but it's not turning fears into safer because that letter there's R. Okay, so E, you can see, okay, yeah, that first one, yep, it would get the S, then it would get the A, then you would get the E. Okay, so that can't be it. Then get the F, and then it would get the R. So again, not quite right. So when you're looking at permutation matrices, you've got to make sure that those rows work out. Turn the right letters on. Now let's look at another example. This is from the 2018 exam. It's question 4. So matrix P is a 4x4 permutation matrix. Matrix W is another matrix such that matrix product PW is defined. Now remember, what does that mean? That means we can times these two together. So we know matrix P is 4x4. That means that matrix W must be 4 by something. Okay, and we might just say 4 by 1. Okay, this matrix product results in the entire first and third row of matrix W being swapped. The permutation matrix is. Alright, so if we want to think about that, we could, have a 4-letter word. Let's have a similar safe. So the first and third row being swapped. So we want to end up with F-A-S-E, something like that. Now there's no harm in you making up, a little word here to help you visualize it, okay? But here, the first and third rows, so the S and the F, these have to be swapped, okay? So let's go through and have a look and test which one would do it. Okay, so here, this first row of A, would that swap? Would that get the third one? No, because that would get the last letter, which would be E, wouldn't it? That would turn on that last letter. Okay, so that can't be it. Okay, B. Okay, yeah, third. That would then put the third letter into the first position. Okay, so that's a possibility. C. Okay, that turns on the first letter. So it's S. So no, that won't do it, will it? D again turns on that first letter. We don't need that. E. No. So it is B. And just to go through to double check, you can see, okay, that turns on that second letter. We don't want it. We're only swapping the first and the third rows. And we can see here in the third row, we're turning on that first letter, which was S. And in our fourth row, we're turning on the fourth letter. So 69% of the state answered that one correctly. So here you had to really understand how these turn on and off and understand, the written of it. I find, again, sometimes putting in some random word helps you understand and test it better, okay? And then, going through and understanding what each of these rows mean.